Hello, so my name's Evan, and I'm going to be talking about this research paper conducted by Gebka and his colleagues, published in 2016, that talks about how military activities contaminate soils and marine sediments with mercury. So basically, I'm going to talk about how they conducted their study, what they found, and the implications of what that means for us. Because understanding what's in our soil is really important for understanding food webs, for understanding plant health, soil health, and general health. So, the authors wanted to examine essentially two major areas near Poland. And so, this is a map showing the areas where they were doing their study. And I will just highlight that. So, well, I'll make a little mark next to it. And so they did three areas, three basins. So Gotland Basin, Gdansk Basin, and Borsom Basin. And then they did, so that was for sediments. So sediments. And then they did sampling for soil sampling at these two, the Hale Peninsula and the Kalbany Peninsula, I believe. And so what they did was they did 30 samples for the soil at different stages, well, different depths, I should say. And so the depths that they did, let me just double check here, was 520 and 30. So 520 and 30 centimeters. And this is going to be important because it's going to tell us something. Now, in order to go forward, though, this is kind of an idea of what they're looking at. So this is a gun range, military gun range. That is ammunition, pretty obvious. And these are the firing lines. And so it's important to think of these things as a whole when we're looking at the data. So what did they find? All right, so for the soil sample, what they found was that the topsoil right here always had basically higher levels of mercury. And the lower depth, as you go lower, right, going lower, they're finding lower amounts of mercury, which correlates back with our understanding of soil in class because it takes time for certain chemicals and compounds to leach or break down. And so that adds on to the persistence of these of mercury because there's a time frame to this to the breakdown, and it doesn't like to hold on to large particles. Mercury likes fine particles, and because of that, well, part of it is influencing why there's more concentration of mercury closer to where the guns are being fired at 1 meter behind, 1 meter in front. And again, that is going to be our highest rate of mercury there, which kind of tracks with what we understand about soil. And um, so we understand that. So what did they find for the sediments? Sediments, similarly, closer to areas that had large ammunitions dumped into the sea or different basins, experienced higher rates of mercury. So for the Godsnick Basin, right here, slightly higher, and then for for the Marxist and the Gotland Basin again right here, higher rates of mercury consumption. Here is the mercury on the left side again, and so what does that mean, right? What does that translate? So we know that there's more mercury near or military activities. Right? What does that mean for humans moving forward? Well, this really becomes a question of management, which is what the authors are discussing. So they basically end with discussing that the issue of terrestrial and marine environmental issues from mercury is because that there's not proper management done with materials that are contributing to the mercury deposits in the first place. And essentially, that inactive grounds become a new area of contention for mercury deposits, and without there being kind of this remediation going on, they just end up there's a higher chance for them to end up back in our environment. So one example, I think, as a solution would be, doing a cover crop that helps with absorption of the mercury rather than it just seeping out, and the potential to affect, like, say, benthic creatures, which so benthic is kind of the bottom feeders, right? So there's water. And remember, they're doing the study on the sediments, right? So they throw a bunch of ammunition in here, ammunition's at the bottom, then there's like the mercury begins to break down, it gets attached to the particles. Smaller organisms eat it, then bigger organisms eat it. Maybe like a fish eats it, and not a very good fish. And then guess what? We end up eating it because we fish for it, and then we eat it. And so we have this food chain. There's that food web of it making its way through the trophic levels back into us. And so not having proper management can be a problem for humans because we are eating so much fish, or we're overfishing. And yeah, so that's basically what the article talks about, and hope you learned something.